Hello, and today I'm here to talk about how mechanical engineering is being used to design wind turbines that can operate in the conditions of the Arctic, and how this is helping with the development and exploration of this region. My three topics will include the problems with the Arctic, how mechanical engineering is being used to design wind turbines that can operate under the extreme conditions of the Arctic, and lastly, how the development of these wind turbines is helping with the development and exploration of this region. The main problems with the Arctic are the extreme conditions created by the weather and the limited amount of infrastructure in place. The average temperature of the Arctic is negative 34 degrees Celsius in the winter months and 3 to 12 degrees Celsius in the summer months. Negative 70 degrees Celsius temperatures have been recorded, and winds can reach speeds of up to 180 kilometers per hour. Beyond this, there is very limited sunlight in the winter, but an abundance in the summer. Small remote communities exist throughout the Arctic. These communities traditionally used to rely on diesel to power their homes and other necessities. This proved to be very expensive, and now these communities are transitioning into using wind power to produce the power needed for day-to-day life. However, under the extreme conditions of the Arctic, materials behave differently, and thus mechanical engineering was needed to design wind turbines that could withstand the harsh conditions of the Arctic. A wind turbine generates electricity by causing uneven pressure on the blades, causing them to turn. As the blades turn, the shaft that the blades are attached to spins. By using a gear train, a smaller shaft spins much faster. This smaller shaft is connected to a generator, which converts the rotational energy into electrical energy. This system is compromised in the Arctic for a number of reasons. Ice accumulation on the turbine can cause the device to not even start during high winds. Furthermore, ice accumulation can cause the turbine to vibrate and cause the material to fatigue because of mechanical resonance. Lubrication is required for the system to operate properly. However, the lubrication must be able to withstand extremely cold temperatures. On top of this, snow and ice can accumulate in the gearbox, and the casing for the gearbox must be sealed against drifting snow. The cold has the highest impact on the bearings of the system due to the torque created by the wind. Although there are many challenges associated with wind turbines operating under extreme conditions, people found a solution. Many mechanical engineers and individuals from other professions analyzed all the components of the wind turbine to identify the right bearing lubrication and understand how cold temperatures affect the material behavior in order to increase structural integrity, reduce icing on the blades, and decrease material fatigue. As a result, they have been able to successfully problem solve to design wind turbines that can operate under these extreme conditions. After all, problem solving and design is what mechanical engineering is all about. Now, several communities in the Arctic are using wind power and, as a result, are more self-reliant, which is especially important due to the limited supplies and infrastructure. Wind power in the Arctic is helping to develop and explore the region. Traditionally, communities in the Arctic have been powered with diesel fuel that would be transported with other supplies every 6 to 8 weeks. This option proved to be expensive and difficult due to the weather conditions of the region. By implementing the use of wind power in the remote communities of the north, this has helped to develop the Arctic by providing individuals who live there with more reliable and cheaper power that is needed for day-to-day life. This is therefore contributing to the development of the Arctic region. Although this technology is mainly contributing to the development of the region, exploration comes hand in hand with development. By creating a more reliable and inexpensive source of power, more small communities may develop, and those in place may expand, leading to the exploration of this region. In conclusion, I discussed how mechanical engineering is being used to design wind turbines that can operate in the conditions of the Arctic, as well as how this is helping the development and exploration of this region. The three topics discussed were the problems with the Arctic, including the extreme cold and the extreme winds, how mechanical engineering is being used to develop wind turbines that can operate under these extreme conditions, and lastly, how this is helping the development and exploration of this region. Thank you very much for your time.